Okay guys, let's take a look at today's lesson. This is Chain Rule Day 1. So let's kind of review where we've been. We've learned the power rule. We know how to do that. We've learned how to take the derivative of a constant. We've learned how to take the derivative of e to the x and a to the x. Remember, the derivative of e to the x is e to the x, and the derivative of a to the x is a to the x ln a. We also picked up another couple of rules, the product rule and the quotient rule. And then most recently we worked on all of the trig derivatives. So now we're going to add the chain rule on top of that. And what the chain rule works for is a function embedded inside of a function. For example, like this. In this example, g of x is the inside function and f of x is the outside function. And that's probably going to be the biggest challenge, is trying to figure out which one is the inside function and which one is the outside function. And there also can be chains inside of chains inside of chains. So that is also an issue that we're going to have to work with. So let's look at what the chain rule tells us. Basically, the chain rule tells us, it's right here, that what we do is we take the derivative of the outside function, copy and paste the inside function, and then multiply by the derivative of the inside function. That's the way the rule works. Again, it's taking the derivative of the outside function, copy paste the inside, and then multiply by the derivative of the inside. That's the rule. Now there's another rule that's associated with this rule. It basically takes the power rule and combines it with the chain rule. It's kind of a power chain rule is what I refer to it. So maybe we have a function inside to a power. We can use the power chain rule, that is bring the n down to the front, bring the function, the exponent down to the front, copy paste the inside, then do -1, and then take the derivative of the outside, the inside. An example of this would be y equals, let's say 3x minus 2 cubed. Okay, let's say we wanted to take the derivative of that and we didn't want to multiply that out 3 times. We would use the power chain rule, this version of the power rule, where we bring the 3 down front, copy paste the inside, subtract 1 from 3, and then we multiply by the derivative of the inside. So the derivative of 3x minus 2 is 3. So cleaning that up a bit, we would get 9 times 3x minus 2 squared. That would be our derivative. So that is an example of this I call it the power chain rule. It's another version of the chain rule. Alright, so that's an example of the power chain rule. Now let's look at some examples of the power rule in general. The first one, we have sine and e to the x. Our first job is to decide which one's the inside and which one's the outside. The inside one, hopefully you'll be able to tell, is kind of embedded inside. So this sine would be our outside function. That would be f if we're going by the rule. And e to the x would be our inside function. E to the x would be our inside function, and it is g. And so what we'll do is take the derivative of that. So y prime equals, the derivative of sine is cosine. So cosine, copy paste the inside. Then we multiply by the derivative of the inside. And we know the derivative of e to the x is e to the x. Now let's rewrite that so that people don't get confused. This would be e to the x times cosine e to the x. And that would be our first derivative with the chain rule. Alright, let's look at the second one. So this one would be y prime equals, alright, what's our outside function? Well, our outside function is e. And what's our inside function? Well, we actually have an inside and an inside. I know, that sounds crazy. So the inside function is secant, but inside of secant is 3 theta. we actually have a triple chain. I know, that's very cool. So let's take the derivative of this. We want to take the derivative of the outside, which is e. We know that e to the x, or I would say e to the box, the derivative of e to the box is e to the box times the derivative of the box. Alright, so the derivative of e to secant 3 theta is e to secant 3 theta times the derivative of secant 3 theta. Well, the derivative of secant 3 theta is secant 3 theta tangent 3 theta, and then the innermost function is 3 theta. The derivative of 3 theta is just 3. So I'm going to put that 3 right up here. So that is our derivative. I know you're going to be kind of upset about this. We can't simplify it. It just pretty much stays that way. So this is basically a function which is 3 theta, which is inside of secant, and secant 3 theta is inside of e. Yes, that's very cool. Alright, our last one that we're going to work with is 2 to the 3x, 2 to the 3 to the x squared. So yes, this is another awesome one. Our outside function is the 2, and then we have, again, this is the like similar to the other one. We have like 2 other inside functions. So the function inside of 2 would be 3 to the x squared, and the function inside of 3 to the x squared is x squared. So we have another triple chain. Alright, so y prime equals, y prime equals, so the derivative of the outside function, the derivative of 2 to something is 2 to the something ln 2. Okay, let's make that, there we go. And then we have to multiply by the derivative of what's inside. And let me change this color. So this part right here is inside. So now we need to take the derivative of 3 to the x squared. Well, the derivative of 3 to the x squared is 3 to the x squared ln 3. And no, we're not done. Now we have to, and let me circle it, we have to take the derivative of this inside piece. Alright, so the derivative of x squared is 2x times 2x, running out of room. So let's rewrite this. Y prime would equal 2x ln 2 ln 3, then 2 to the 3x squared, and 3 to the x squared. Isn't that gorgeous? Look at that. It's very cool. Alright, and that is day 1 of the chain rule.